This is a short video to walk through how you would do a chi-squared calculation in Excel. Now, Excel actually has a ton of statistical calculations that are embedded in the functions, but the problem with statistics is usually not doing the calculation, it's understanding what the calculation means. So for this chi-squared, it's good to just actually work through the calculation yourself. It's not very hard. And you can see how the calculation is done, and you can actually see how the probability level is determined from the end of that calculation. So let's just go through an example right now. This spreadsheet's available also online. So we have an assignment. We have three colors, blue, green, and red. Let's just say those are the three M&M colors that we have. And in a bag of 100, let's say they're evenly distributed, a bag of 99, and there should be about 33 of each. Now when you pick these out, we're going to again add up to 99 in this case, because we're going to assume let's pick the whole bag. But let's say we got a bag where there were 35 blue, 31 green, and 33 red. Double check that our totals are correct. Let's do this so we can play around with the numbers in a minute. Okay, so we expected even distribution. We got something that's a little bit different. First step in the chi-squared is calculate the difference. That's the observed minus the expected. So in that case, we say equal observed is actual, which is C6, minus the expected, which is B6. We have a difference of 2. Great thing about Excel, just copy these down. So our first one, we have 2 more than we expected. Our second one, the greens, we have 2 less than expected. And our reds, we got exactly what we had expected. Now the reason we square this number now is because we're interested in the difference with the mean, not the direction of the difference. And so by squaring, we remove the negative sign. And the way you do a square in Excel is you say equal this cell, E6, and there's a little hat right above the 6 key. It's a little like arrow pointing up, which is going to say, whoops, squared. So you say E6 in this case, little hat, and then squared. So 2 times 2 is 4. Minus 2 times minus 2 is 4. And we'll do the last one, even though we know what it is, which is 0. Okay. So now we have the difference squared. So last step in the calculation, so we just did in the equation the OI minus EI, the observed minus expected, for each of the groups, and we squared it. Now we need to take each one of those and divide by the expected. So for that, super easy. F6 divided by our expected was 33. B6, okay, 0.12. Do that for all of them. And then our total is the sum of those three. 0.024. All right, so the last step then in the chi-squared is to ask whether or not this is significant, and that's based on this probability distribution, which we won't go into where that came from right now, but you have 2 steps. First is to get your degrees of freedom. That's number of groups minus 1. So in our case, we have blue, green, and red. 3 groups. Minus 1 is 2 groups, so we have 2 degrees of freedom. So we're going to be looking in this column with the 2. And our value is 0.24, and we're going to go see where that value sits. Now the way that scientists typically use this is that somewhat arbitrarily we say that something is significant when 95% of the time we're going to get that result, basically. And so that, in this particular case, our number would have to be more than 5.991 to be significant at the 5% level, where we're basically correct 95% of the time. In fact, we're way over here in 0.24, somewhere between being correct between 5 and 10% of the time. We're being wrong between 90 and 95% of the time. So not significant. Okay, so basically our test here is that our observed numbers are not significantly different from our expected numbers. Now if you just want to see, it's a nice thing about Excel as well, is that we can change these numbers around. Let's say we got 20 and 40 and 6 in these. Now you see our chi-squared statistic is now 28.7. So again, if we look at the degrees of freedom of 2 right here, we're incredibly significant. So we're way out here beyond the 0.5% confidence limit. So basically 99.9% of the time, these two groups are going to be different. Something's really weird about the M&M bag that we got. It is way outside the norm. So the basic idea with the chi-squared test is that you're able to quickly determine whether or not your observations are matching your expectation for some kind of distribution. So hopefully you can work through this. It's more fun when you're actually doing this with M&Ms. I'm going to post this spreadsheet up online. You're welcome to use it. You have to do the calculations yourself, though. All right, good luck.